Okay, answers. Acids and alkalis assessment. So mark your work and make corrections, add up your scores and submit. So the first question, quite straightforward. Acids taste sour. Alkalis feel mostly soapy. Vinegar is an example of an acid. Moving on, a pH probe or universal indicator can be used to see whether something is an acid or an alkali. Question 3, pH 1 indicates a strong acid, pH 4 strong alkali, pH 7 neutral, pH 4 weak acid, and pH 9 weak alkali. Question 4, acids and alkalis react. They form a neutralization reaction where they produce salt and water. An example of neutralization is hydrochloric acid added to an alkali, sodium hydroxide. Out of this chemical reaction, this here, sodium chloride, is the salt that is produced. Now, if we wanted to produce nitrate salts, we will need to use nitric acid, hydrochloric acid for chloride salts, and sulfuric acid for sulfate salts. Now, one of your tasks was to look at how we determine whether something is an alkali or an acid. We looked at 3 techniques in one of the videos. One was red litmus paper, one was blue litmus paper, and the other one was using a universal indicator. Now, if we are using red litmus paper, it will stay red if it's an acid, but it will turn blue if it's placed in a alkali. A blue litmus paper will stay blue if it's an alkali, but it will turn red if it's an acid. And universal indicator has 14 different colors. Red if it's an acid, purple, blue if it's an alkali, and then the colors in between. So if red litmus paper stays red, blue litmus paper turns red, and universal indicator turned orange. Now this indicates that it's an acid. How strong of an acid, the universal indicator will give us more of an idea. So it's orange, so it's not very strong acid, and the colors beyond red, it's orange, so we're looking at a pH around about 3 to 4. Now, red litmus and blue litmus both turn blue, so we know it's an alkali. Because the universal indicator is indicating a color of purple, now that's on the right at the far end of the color spectrum for the universal indicator, and that is a strong alkali, and we could have given any number between 13 and 14. Again, litmus paper stayed red, turned red, indicating it's an acid. Universal indicator is showing it's red, and red on universal indicator is a very strong acid, so that's a pH of 1 or 2. Question 7. This is the 7A is where most students will make a mistake, and the reason is acid is reacted with a metal. Now, if you look at the reaction, hydrochloric acid has hydrogen and chlorine in it, and zinc, there's only zinc there. So we can't actually produce water as we normally do in our neutralization reactions because there's no oxygen here. So zinc will attach itself to the chlorine, making zinc chloride salt. What's left over is hydrogen, and hydrogen gas on its own. So the mistake that students would have made here is written water. Now, this is copper oxide. Copper oxide is an alkali reacting with an acid. And here we do have a neutralization reaction because it's an acid with an alkali, not an acid with a metal. Okay, so an acid with an alkali gives you a salt and water. Okay, so copper chloride is the salt and water. Potassium hydroxide plus hydrochloric acid gives us potassium chloride and water. Question 8. You have got a student that has 100 centimeters cubed of hydrochloric acid. They split the 100 centimeters cubed into 2 beakers and they fill up equally into 2 beakers. So that means there's 50 centimeters cubed of hydrochloric acid in each beaker, and then they fill it up. They add in water to make the solution to 100 centimeters cubed. Now what you've got is hydrochloric acid mixed with water in each beaker. So each beaker has half the acid particles compared to before, and as it's mixed in the same volume with half the acid particles, you are going to get half the concentration. Final question. There's 4 points that you need to address, and this is where attention to detail is required. So there are 4 separate points that the question wants you to address. First, it wants you to address how we are going to figure out the pH of the soil. Then we are going to find out then we need to make a couple of statements of how we are going to make sure that the crop gets the best possible yield. So the soil is at 7.5. The third point is discuss what factors might change the soil's pH naturally and what we can do about that to ensure that the pH is going to remain at 7.5. So the first point, find out how to test the pH of the soil. Add universal indicator to the soil to determine the pH. There's 1 mark. Now, the soil's pH could be more than that, or it could be less than 7.5. So if the soil is too acidic, that would mean that it's between 1 and 7. Then we need to add an alkali to increase its pH. If the solution is too alkaline, then we could add an acid to reduce its pH towards 7.5, and that will pick you up another 2 marks possibly here. And in the question, he also talks about discussing the idea of neutralization. So we could add a point in here. So when an acid is mixed with an alkali, this is the process of neutralization, and this adjusts the overall pH towards 7. Now, what could naturally change the pH of the soil? Well, it could rain, or water could leach from other fields, soil nearby, and mix in with the soil that we are looking at. when we are trying to grow more crops, more yield, we add fertilizer. All of these could change the pH of the soil. So what we could do is we could continuously monitor the pH of the soil over a period of time, and we could add alkalis or acids to adjust the pH depending on how the pH has changed. So that picks you up your fourth and fifth possible marks, even six there was about neutralization. So what I've written here is six possible marks. If you mention four out of those six, that would pick you up 4 marks. Now mark your work, make corrections, and submit your work with a answer, with a mark written at the front here. So if you could write down your mark out of 30 at the front here, that would be great. And then you can submit.